Hello, space enthusiasts. Welcome back to Universions. Today, we're diving into the cosmic wonder of Comet 3I Atlas, an interstellar visitor from beyond our solar system. Watch as it races towards the sun at incredible speeds, a true wanderer of the stars. To understand this comet journey, let's start with the fundamentals. Sir Isaac Newton's first law says objects in motion stay in motion unless acted upon. That's why this comet keeps speeding through space. His second law, force equals mass times acceleration. The sun pulls massively and accelerates the comet as it gets closer. His third law, for every action, there is one opposite reaction. That is why the sun pulls the comets close by. Finally, his law of universal gravitation tells us that every object in the universe attracts every other with a force that's proportional to their masses and inversely proportional to the square of the distance between them. In simple terms, gravity is what keeps planets in orbit and pulls comets like 3I Atlas on their curved paths. As October draws to a close, the night sky fills with worms, shooting stars, the hunter's moon, and now Comet 3I Atlas nearing its closest point to the sun on October 30th. Throughout history, comets have sparkled mysticism. Ancient cultures saw them as harbingers of doom or divine messages. But let's separate myth from science. These are icy rocks from space, not supernatural science. Still, its timing is perfect for Halloween. Imagine this ghostly visitor from another star system haunting our skies during the spooky season. No curses here, just cosmic beauty. Newton's gravitational law can be described as follows. Here is our comet that passed through a trajectory like this, and here is our Earth. In between, there is some distance. Therefore, there are going to be some attraction between the comet and the Earth, which is proportional to the following. The force is proportional to the gravitational Newton constant, which is 6 times 10 to the minus 11 meter cubed per kilogram per centimeter square, per every second squared, and proportional to the Earth mass and comet's mass, and inverse proportional to square distance between Earth and the comet. Now, we can initially measure astrometric values as follows. We can measure the eccentricity, the perihelion distance, the semi-major axis, and so on. And using these measurements, we can describe the solar system and its motion. How to do that? From Newtonian's equation of motion and using the eccentricity, which is way bigger than 1, we can find the polar equations for the comet position to follow this law. Then we have the velocity via this Viva equation that is given by this formula. And then the true anomaly mu, which is given by the trigonometric and hyperbolic tangent functions. And F, which is the hyperbolical anomaly, which can be given by the time position link, the hyperbolic Kepler equation that describes this hyperbolic anomaly F. Now, using initial measured astrometric values, we solve numerically the hyperbolic Kepler equation for F at different times, and then we can compute the position of the trajectory and the velocity of the trajectory. Check out this custom animation I made with Python and AstroPy. It shows the comet's hyperbolic path cutting through our solar system. Planets orbiting steadily while 3I Atlas zips by from September 2025 to January 2026. Watch it approach, passing through the perihelion, swing around the sun, and head back to the stars. Note the perihelion position, the position of the comet which is closer to the position of the sun. Want to spot it yourself? Use apps like Stellarium for positions. Amateur telescopes of 8 inches or larger might catch it in Virgo pre-dawn, but pros like the 2.5 meter Nordic optical telescope in the Canary Islands have imaged it clearly. Space telescopes, ESA ExoMars, Mars Express observed in early October, and NASA James Webb Space Telescope could provide detailed views. Even the GOES 19 satellite might glimpse it during solar conjunction on October 21st. For a fun twist, think of this comet as a cosmic werewolf. It transforms as it nears the sun, outgassing ice into a glowing tail, much like legends of shapeshifters under the full moon. But remember, that's folklore. The real magic is in the science. Thanks for joining me on this interstellar adventure. If you enjoy it, hit like, subscribe, and turn on notifications for more cosmic content. Clear skies, everyone.
Spooky!